Cool. Welcome, everyone. I'm Will Crow, the co-founder and CEO of Here. Thank you. Woo! I wanted to start tonight by thanking so many people for coming in person. There's over 100 of us here tonight. Some of us have flown in from overseas, from as far away as Japan and other places in Asia Pacific. We've also had a lot of people fly in from interstate as well, so really appreciate you all coming here tonight. We also have 200 people watching live online as well, so thanks for being there and taking part, even though if you can't be here in person. One of the first things I wanted to mention, you might notice something a little bit different about our logo. Up until tonight, we were called Here Robotics. Now we're Here, or HEO. So there are a couple of reasons for the change. I think firstly, not many people knew why robotics was in our name. It's part of our culture, part of how we came to be. But I think Here by itself just reflects where we're going and the maturity of the company going forward. So really excited about that brand change, as small as it may seem. So again, welcome to T-Minus. T-Minus is our yearly product release event. And last year, we released Here Inspect, and this year we'll be releasing some other new cool features. So firstly, I want to talk about what we do at Here. At Here, we believe that space should be easy. A lot of people say space is hard, and we think about, well, why is that? Why should that be the case? And really, the way we think about this is that it's not really hard. There just isn't enough information. There's just not enough data out there. So really, a lot of things that we do here on Earth is really hard. It's really hard to make a car, whether it be powered by electricity or whether it be powered by gasoline. It's really hard to make an airplane. Space is hard too, but it's not more hard than any one of those disciplines. So the way we think about solving this is just to create a whole bunch more data. We do this by taking images of things that are in space and then trying to pull as much information and interesting stuff out of those images as possible. The way that we do that is by what we have called flyby inspections. We have a satellite with a camera, flies past another object really fast, sometimes at 15 kilometers per second or faster. And collecting images as we go by. And what that means is that we can get to a lot of objects really quickly, and we can collect a lot of information about a lot of objects as we fly past. And today we help governments, both civil as well as the intel community and defense community, as well as commercial satellite operators to really help maintain their assets in space. So we're the first commercial company to make this a possibility worldwide. We've been operating for over a year now with Here Inspect. And I just wanted to quickly go through some of the names. So the industry is still figuring out what to call this capability. And so I just wanted to mention there's 3 words or 3 names that you should look out for. The first is flyby inspection. That's how we started at Here, calling this technology. A lot of people are calling this space-to-space or sat-squared technology. That's more of a historical name that's applied to this. You might see a lot of NEI as well. So that stands for non-Earth imagery or non-Earth imaging. And I really want to, terrible name, but that one seems to be taking off the most. So look out for NEI out there when you're thinking about Here and what we do. So last year, our first unveiling, Here Inspect, the first time ever that you could get data on your satellites taken from other satellites with all the benefits that comes with. And I'll just remind everyone that when you take a photo of a satellite from another satellite, firstly, you're much closer. There's a lot of other benefits too, but the higher up you go, the further away from Earth you go, the better it gets compared to other options. So we unveiled Here Inspect last year. Since that time, in the last 12 months, we've had over 900 successful missions for different clients around the world. We've got customers in 3 different countries, so that's the US, Australia, and the UK. We've actually got offices in all three of those countries now, which is really exciting. We just opened our US branch a couple of weeks ago. We're going global. We're starting to work with potential customers, hopefully soon to be customers in other parts of the world as well. So a lot's happened in the last 12 months. But with every new technology, there's a lot of bugs to fix, a lot of learning in the community. And we've been doing that at Hero, and our customers have been doing that. And there's three things that they really care about. So we'll click to that really quick and then talk about how we're working with that. So firstly, they want higher resolution. They want more information. They want better images, essentially, and all the information that comes out of that. So we get that. You want an image of your satellite or whatever it is you want to get photographed in space, and you want to really be able to see with your eyes what that is. And that means that the computer algorithms, et cetera, can really understand what's happening better as well. They want the information faster, so preferably within 24 hours. Here is not quite hitting that benchmark right now, but we're hearing what the customers are saying, and we're really keen to get that information as fast as possible. They also want more coverage. You want to come to Hero Inspect, and you want to know that we're going to be able to image your satellite or image the thing that you want to know more about. So we get that too. You don't want to be guessing before you log in. The last thing is, so outside of the three, is they want killer apps. So they want to really be able to solve their problems. So being able to do that is, hey, little girl's just looking at me. Hey, Bubby. They want killer apps as well. So they want to be able to solve their problems really well using the information that we have. They don't want to have to think too hard about that. So we've been looking at fixing all three. So first is higher resolution. We're fixing this in a few ways. So first, we're getting more partners. Typically, the way that we work at the moment is we use software with our partner satellites. So our partner satellite will have a camera. We use our software to make it do what we need to do and collect images of other objects in space. So we're working with more of these suppliers. But the thing that has had the biggest impact is in blur. So remember what I was saying? Some of these objects are passing each other 15 kilometers per second. That's fast. And sometimes you get a blurry image out of that. But what we found is that we could really work with our suppliers, get rid of that blur. And we've been able to reduce blur by 10 times over the last 12 months. So we've got a side-by-side here. So we've got an image that we took 12 months ago on the left. It's pretty blurry. You can't understand quite as much data from that. On our right, we have an image that we're able to take with some of our more enhanced software features after we did a lot of work. And you can really see the difference. You can see the clarity on the International Space Station. By the way, huge spacecraft, but really small devices connected with it. So I've blown up 2 Russian Progress modules there. On the first image, you can't really see those at all. You can see something's there, you can't really tell what they are. On our new enhanced image, you can see the solar panels, you can see the dimensions, you can really see what's going on those spacecraft. So 10x reduction, which has been really awesome. And thank you. Had a very small clap there. Thank you for that. And really, we're going after this problem and trying to squeeze even more resolution improvements out using purely software for now, but using more and more sensors in orbit as well. Secondly is about getting faster. And this is all about automation. So identification of the opportunities. So first getting the image data or what our customer wants from them. Moving into image retasking. So that's the ability for our system to retask a satellite and make sure that we get the right imagery back. And lastly is detection. When we get our images back, it's just a huge amount of data. And what we did to begin with is worked with people, our great analysts, to pour through that data and find the satellites, find those that nugget of information. What we've been able to do, and we're the first company to be able to do this because we're the only ones with a large data set to be able to train ML algorithms, but we've started to be able to do that. We have a system, we call it Megatron, and it pours through all the data when we get it back from our suppliers and really works out where the satellites are in frame and really makes that process a lot quicker. So we've gone from having to have humans in the loop to instead being human supervised. So we run this system, then a human will pour over that data afterwards and check yes or no whether a satellite's in frame, rather than having to have a human look through an entire data set and really find where things are. So that's been unique to us because we're the only ones, again, with this commercial data set that we've been able to use. And as time goes on, we'll keep building that up and keep building that moat, which is really exciting. Going back to image retasking and the opportunity identification, we have an automated system now that we can tailor to specific users. So if our user wants really fast data back, but doesn't mind too much about the resolution that we might get in that fast time, we can tailor that to their needs. If they need a really, really nice image and don't mind waiting a while, we can tailor that as well. So we've been able to really move towards this tailored system, but be able to scale that really quickly because we're using these automations that just weren't available before. Talking about coverage. So I think for a lot of our customers, this is a really big one. A lot of our customers are saying, we need you to go to the orbits where our satellites are, which aren't necessarily where we operate today. So I'll just remind everyone, we have the largest non-Earth imaging fleet already today. We have 39 sensors that we have access to, which is really exciting. We calculate that that's more than half already of all the Western satellites that can do this kind of imaging or have that potential. But that's not enough. We've got to go to the orbits where our customers are sitting today. So we have a few ways that we're looking to solve that.
Hello!
Sorry. This is one of our suppliers. So sorry. I'll preface this. So firstly, I did want to get some messages from our suppliers. So the way that we operate today is that we take our software and apply them to our suppliers' satellites, and they have a few words to share. And if you're a potential supplier with a great satellite that you want to monetize, then we want to speak to you. And we'll let Luciano do some of that talking now.
Hello, HEO Robotics. This is Luciano Gieso from Satellogic. I'm so happy to be joining you here on your T-minus event. I want to give you a brief word of congratulations and to celebrate our partnership. So Hiranya, Will, and the rest of the HEO team want to let you know how happy we are to be able to provide value together to our end clients, and we hope that we have a great relationship together for many more years to come. Thank you.
Thank you, Luciano. He's a great guy. And we have another of our suppliers, Axel Space, that's coming up. Hopefully it won't be quite as surprising this time.
Hi, Hellotics family. This is Tats from Axel Space, based in Tokyo, Japan. With a strong partnership with HEO for over a year now, HEO has expanded our business in the field of SSA. Before the relationship with you, HEO, we would not have challenged ourselves to explore the new business field of SSA without compromising the core mission of Earth observation data acquisition as the pure addition to our business portfolio. We look forward to an even more solid partnership with HEO and to going further beyond our expectations.
Awesome. So thank you both. So sadly, they can't join us today. They're a little far away, but we're really grateful to our suppliers. We continue to work with them, continue to change the way that we operate, and continue to bring this new industry into being and providing new revenue stream to them as well, which is really important. So when we talk to our customers, there's three areas that they talk about operating in. So one is low Earth orbit. So that's where we operate today. That's largely in green, a little bit in orange in this slide here. There's high low Earth orbit. So this is a little bit beyond where we operate today. So that's typically between 700 and 1,200 kilometers above us. And there's geostationary orbit as well. So this is where all these valuable communication satellites that you've heard of operate today. So our customers have asked to go to these two newer domains as well, and we're really committed to do that by the 2025 timeframe. And the way that we're doing this, so these orbits don't typically have cameras there already. So we've had to really think differently about how we operate. We're a software-first business, but we have had to think about hardware as well, and we've got a really great hardware team. And what we've been able to do is actually launch the first commercial non-Earth imaging camera, and we did that just in the last couple of months. It's in orbit today. It's healthy. We haven't been able to... Oh, thank you. It's quite an achievement. And I think the other thing that's really interesting about it is that it was all made here in Australia except for the imaging chips themselves. So we were really working on bringing our supply chain really close to us, and we're able to do that, which is really exciting. So these images, we have one in space already. We've already built several others, some of which have already been sent to other suppliers. And this is all about how do we think about filling in those gaps that you saw in that previous slide, with the acknowledgement that operators that go to those orbits, satellite operators, wouldn't normally have cameras themselves. So we need to help them out a little bit there. And at the same time, we're able to build a camera that really matched our needs based on the tens of cameras that we'd already used and we'd already tested in space. So one great thing that's already happened or will happen once we're able to open the payload door is that low Earth orbit is now fully covered. So that orange band you saw on the other slide, there was a kind of little gap that we had. We could image things in that band, but we didn't have quite the resolution that we really wanted. Now that's entirely filled. And we're looking to accomplish that for high LEO as well and geostationary orbit also. Another thing that our customers want, as you know, is higher resolution. So for geostationary orbit in particular, we were really challenged by our customers to think about how can we get the resolution that they need. And one of the answers is bigger cameras. So we've already got the kind of second generation camera under production. It's called the Adler, for those that know their Holmes mythology. And it has much higher resolution. It's a bigger camera, so it's got a larger aperture. It's mainly built in Australia. We've had to go offshore a little bit and extend the supply chain, but a lot of it's still built in country, which is really exciting. In fact, I saw images of the first one already machined and coming into our lab down at Botany, which is really exciting. So we're really excited about Adler. This time next year, we should be able to talk a lot about it, and hopefully we'll have a display model to show you then as well. And the first of those should already be shipped off to our suppliers around that time. So we're really excited about Adler coming on the horizon. So, to the software. We're a software-first company. I haven't spoken about software much over the last 10 minutes, and really want to get into that. So, what we found from operating over the last 12 months and getting so many successful images back to provide to our clients is that there was just too much data. So this amount of data had just never been available before in this format. And our customers didn't really know what to do with it. And that's fair. When you're bombarded with a lot of information, it really makes sense to try and put that in a way that we can understand it better. So we've now object-oriented all of the information. So instead of looking through images that you as a customer have purchased or the information associated with those images, you can now click on an object and go through that object, and it'll have all the associated data with that now. We'll have a little video to show you in just a second. But before that, part of the beauty of having so much data is that now we can see an object under construction. So what we have here is tens of data sets of the Chinese space station being built. This is the first time we've released this imagery publicly. And you can see a story over, I think this is over an 18-month time frame. So slowly, it's under construction. There are satellites coming and going with different modules to the Chinese space station. And what we were able to find, so the Chinese actually published the majority of, I guess, orientations that its space station is going in. But this orientation here, for example, was not published publicly, and we're able to see that with the imagery that we collect. So going back to like the civil government use case, this is really good for ensuring that people are doing what they say that they're doing, and really trying to understand that those processes are being followed. So really beautiful spacecraft. It appears to be finished construction now, but this was really fun to watch over the last 18 months. And this is the last image here. Really beautiful. Thank you. And thanks to our team for putting that together. What you saw in that image as well is that we do 3D renders of all the satellites that we image. So sometimes it's hard to tell what's in an image. It's a bit of a blob. And we make that easier by 3D rendering all the spacecraft that we image as well. So this next one, for some of you, you're going to be really excited. For some of you, it's going to be very surprising how excited some people are. And that's okay. But I might just put it in context for you. So I had a look at Google Scholar, which is a database with all or most papers, academic papers that are written in the world. And for attitude estimation of satellites, I put those 3 keywords in. I had 228,000 results. This is a big problem that hundreds of thousands of academic hours have been spent trying to solve. And I think at HERE, we knew the answer the whole time. We're like, well, just take a resolved image of it and then use fantastic computer processing capabilities, many of which we have in-house already. And then you can tell the attitude of the object. So for those that don't know, attitude is really understanding the pointing direction of an object. We worked with a bunch of our customers to understand the attitude of several objects, including the Hubble Space Telescope that you can see here in this image. And we found we were good to within a few degrees the majority of the time. And when we weren't, it was typically due to some kind of interesting maneuver that was happening at the same time. So this is groundbreaking. For those of you that are excited, we're excited too. For those of you who aren't, that's okay. But trust us, it's really cool. So this is now available for every object that we can image that's of mini size or larger. So that's thousands of objects. And we can help people understand which orientation debris is in if they want to remove debris. We can help people understand if their satellite's in safe mode or not, so that can help them understand if there's a way to recover their satellite or not, if it's not communicating back to the ground. It can understand which way a docking port is pointing and things of that nature. So this is why it's really groundbreaking for a bunch of people. And either we have a video from one of our customers coming up, or we have a HERE in-house video. I don't know which, so I'll press the button and we'll find out. Okay, this is our in-house video. So this is just showing you HERE Inspect and what it looks like today. So this is the object page I was talking about. And as you can see, tens of data sets associated with many of our satellites, and so having an object page is really the best way to think about it. We also have orbital activity, so we found that a lot of the images we were taking only made context or made sense with the context of the orbital activity. So you can see here with the International Space Station, it was kind of moving altitude quite a lot and moving inclination a little bit there as well. We're moving to the Hubble now. This is going into our attitude determination piece. So you can see here there haven't been many maneuvers. There's a slight decrease in altitude over time as it's slowly deorbiting, for those that know. But this is the attitude piece. So you can see here with multiple timestamps, we've taken attitude at different times. And we've been able to verify this, so the Hubble actually publishes where it's pointing at any given time. We've been able to verify it with that data set as well, which is really exciting. And we've been able to verify with several of our customers who are operating satellites as well. So this next video is from one of our customers. It's from Astroscale. It's from Meki, who's based at Astroscale. And we'll talk about, sorry, some of the team's laughing at me, which is fair. We'll talk about, or she'll talk about some of the great work that we've been doing together.
Here at Astroscale, we have used HEO Inspect to observe a number of objects of interest in order to assess their tumbling or spin rates. This is vital for us to understand, as in order to safely perform active debris removal or end-of-life capture, we need to accurately understand the motion of objects and the way in which they are rotating. HEO Inspect allows us to perform these observations of objects from space rather than from ground, which has enormous advantages. With the support of HEO Inspect and their resolved imagery, we are able to work towards making space more sustainable for future generations.
And thank you, Meki. So that's the end of the presentation again. So just to recap, we've been operating for 12 months. We're the first company in the world to have a commercial product doing what's now widely known as non-Earth imagery. We've been producing hundreds of data sets that we've been helping their clients with their various problems. And we also acknowledge that our clients really care about higher resolution, more timeliness in terms of data transmission, more coverage, and they really care about killer apps. And as you saw there from Meki, they really care about attitude determination, even though most of us still don't know what that is. So thank you very much. It's a real pleasure having you here tonight and online, and looking forward to joining the conversation with you after this. Thank you very much again.